Hello guys, I hope you all stay well and safe. Welcome to my geometry video, which is about area of triangles and parallelograms. It is important to remark that the material that I have used in this video was sent to you through email a few days ago. On the other hand, you can also check it through Google Classroom. I have created a Google Classroom for you, and I have sent invitations to all of you, so please accept the invitations and join the class so you can download this material, videos, assignments, and many things that I'll hopefully be posting on a regular basis. Okay? So the first thing that we need to remember to calculate areas of triangles and parallelograms are the formulas. Okay? So what is the formula to calculate the area of a triangle? It's this one right here. So as you may know, the area is 1/2 times b times h, where b and h represent the base and the height of the triangle. Also, in the very same way, the formula for the area of a parallelogram is very similar. It's namely b times h, where b and h represent the base and the height of the parallelogram. So suppose that we want to calculate the area of the triangle given in picture A. Okay? So the first thing, of course, we need to do is to write down the formula for the area. We know that that is 1/2 times b times h. Okay? So we need to find the values of b and h from the information provided in the picture, so that we can substitute those values here and then get the value of the area. So, but if we see the picture, we have these two sides with length equal to 7 and 4 respectively. So which one of those should we pick to be the value of the base? Well, we need to know that the value that we pick for the base will impact the value of our height, because we need to remember that the height in a triangle, okay, depends on which side you select as the base. So if you have a triangle like this one, and let's suppose that we're going to select these 7 units to be the base. So we select this line segment, okay, with these 2 vertices here. So the height will be the perpendicular distance that we can have from the third vertex of the triangle, which is here, to the line that contains the line segment defining our base. So if this is our base, so if 7 units will be our base, so this will be our height, because this is in fact a perpendicular distance from the third vertex to our base. Okay? So, and how do we know that this is a perpendicular distance? Well, you see here this little square. We remember from geometry that if in a triangle you see a little square located in one of the vertices, that means that you have 90-degree right there. Okay? So since this is a 90-degree angle, therefore this base, this side, is perpendicular to this side, and vice versa, of course. So if we choose this side to be our base, therefore this will be our height. So now we can use these pieces of information and substitute here in the formula and obtain the area of a triangle. So let's do so. So this is going to be 1/2 times b, which is 7, and now we know that h is equal to 4, so we know 7 times 4 is 28, so we have to multiply 1/2 by 28, but we know, for example, that multiplying 1/2 by 28 is the same as dividing 28 by 2, right? And this is 14. So the area of our triangle is going to be 14 square units. Okay, so now the question is, what happens if we choose 4 to be our base? If we choose this side with 4 units to be our base, will the result change? The answer is no. Because if we choose this side to be our base, so then we know that since again this is a 90-degree angle, this side will be perpendicular to this side. So therefore this will be our height. So the only thing that we have to change in the formula is the order of these two numbers, because now our b will be 4 and our h will be 7. So we will have 4 times 7, which is of course 28, and therefore we have the same result. So the selection of the base impacts the value of our height. But in cases like this, the way you select the base and the height is not relevant, because you preserve the value, okay? Because the two sides are given in a triangle, okay? So this is the area in this case, 14 square units. Okay guys, let us consider a second example. Let's go and solve exercise C from the material. And in this case, we have this new triangle, okay? The new triangle is different from the previous one. So we see that we have this vertex here, line on this line, so the triangle is somehow inclined. Okay, so we write down the formula for the area of the triangle, which is 1/2 times b times h. So we need to find the value of the base. We need to choose the value of the base. But according to the picture, we realize that there is only one side in this triangle for which a value has been assigned, namely these 4 units. So we're going to choose necessarily our base to be this side here, okay, with length equal to 4 units. So how do we find the value of our height? Okay, so when we see the picture, we are tempted to say, well, the height is equal to 11 units, and it's right. So, but why is that? So if we check the definition of height of a triangle, we remember that once we have picked our base that has these two vertices, so we take a look at the third vertex, which is right here, and we consider the perpendicular distance from that third vertex, okay, all the way up to the line that contains our base. So the line that contains our base, in this case, is this dotted line, okay? So this perpendicular distance, this distance right here, will be our height. So namely, this is our height. So we need to calculate the value of this height. But if you see from the picture, we have also this dotted line right here, which has 11 units, okay, as length. And this is exactly the same as this perpendicular distance. And the reason why this is true is because we see here that we have this little square again. So this refers to 90 degrees again. So we know that this line, okay, where the third vertex is lying on, this line is perpendicular to this line containing the base. So we know that this is in fact a perpendicular distance, okay, from the third vertex to the line containing the base, and therefore we know that the height for our triangle is equal to 11 units. So once we know all this, we can substitute 4 and 11 in our b and h respectively, and then we find the value of the area. So let's do so. So this is going to be 1/2 times 4 times 11. Okay, so 4 times 11 is 44. So we have 1/2 times 44, and this is the same, of course, 44 divided by 2, which is 22. So we know, therefore, that the value of the area of this triangle is 22 square units. Okay, so this is the answer. So could we choose another value for the base? No, because we don't know anything about the rest of the sides of the triangle. That's why our only option for the base in this case was these 4 units right here. And then we deduced from that and the information of the picture, we deduced the value of our height. Okay? Okay guys, let's finish this video by considering an example where we calculate the area of a parallelogram. So to do that, let's consider exercise E from the material. So we have to calculate the area of this parallelogram. Okay, so we know that in this case the area is just b times h, where b and h represent the base and the height of the parallelogram. Okay, So remember that in a parallelogram, two opposite sides are always parallel, okay? So this side here will be parallel to this side here, and this side here will be parallel to this side here. Okay? So on the other hand, we notice that this is the only side on this parallelogram that has been assigned a value, namely 6 units. So we're going to take this side as our base, right? So we have that B is equal to 6 units. So now we have to find out the value of the height. So in order to do that, we follow the guidelines of the same definition that we have for the height of a triangle. Namely, once we have selected the two vertices of the base, we look at the opposite vertex right here, the third vertex right here, and we calculate the distance, the perpendicular distance from that third vertex to the line containing the base. But the line containing the base is obviously this one right here. So this is in fact a perpendicular distance, because as you can see, we have this little square that indicates that here we have a 90-degree angle. Therefore, this is a perpendicular distance, okay? And we can consider h to be equal to 3 units. So now we know that this is 6 units and h is 3 units, so the area of this parallelogram is 6 times 3, which is 18. So therefore, the area of this parallelogram is 18 square units. Okay? So I invite you to solve the rest of the problems that can be resolved using the same arguments, the same ideas. And please, if you have any question, do not hesitate to write to me and let me know how can I help you. So, and I'll be glad to help you through email and through Google Classroom. Okay, so see you. Thank you.